I want you to start by closing your eyes. We need to do a little calibration before we get into the heavy stuff today.
Go.
I want you to picture the sun. It's familiar, right? Big ball of fire, dominates the sky. You could fit a million Earths inside it.
The biggest thing we can comprehend, really.
Exactly. Now, I want you to delete the sun from your mental image.
Gone.
And in its place, I want you to put a different star. A star so mind-bendingly colossal that if you dropped it right where our sun sits, its surface wouldn't just swallow Earth. It would extend past Mars, past the asteroid belt, and it would swallow Jupiter
Whole.
whole.
That is a terrifying image. It's hard to even process that kind of volume. You're talking about a radius of over 700 million kilometers.
It's just a number at that point.
It is. If
Yeah.
you were flying a commercial jet, cruising speed, it'd take you about 6 months to fly around our sun. To fly around this monster, you're looking at nearly 1,100 years.
1,100 years. That's just staggering. And that monster, that is the subject of our deep dive today. We are talking about a star called WOHG 64.
Yep. It's sitting about 160,000 light years away in the Large Magellanic Cloud.
That little satellite galaxy orbiting our own Milky Way.
It is arguably the largest star known to science, or, at least one of the top contenders, a true Leviathan.
But we aren't just talking about it because it's big. I mean, we love big stats, but we're here because as of today, January 21st, 2026, the astronomy world is kind of recovering from whiplash.
Serious whiplash, yeah. Just 2 weeks ago, January 5th, a new paper dropped that completely solved this dramatic mystery about the star.
A case of mistaken identity, really.
It is. We basically watched this star fool the entire astronomical community. It's a classic scientific detective story where the culprit, well, it turns out to be gravity.
Because for the last year or so, we thought we were watching it do something impossible. We thought it was physically transforming, evolving in real time.
Right, the headlines were everywhere. Red supergiant turning into a yellow hypergiant.
Now, the data says not so fast.
Exactly. The story of WOHG 64 is a masterclass in just how messy astrophysics can be.
Yeah.
It turns out the star wasn't evolving. It was hiding a secret partner.
So that is our mission today. We are going to unpack the behemoth. We're going to look at how it tricked us, what actually happened, and what this tells us about the violent, dusty deaths of the universe's biggest stars.
It's a fascinating ride. Let's dive in.
Okay, I want to start with the baseline. Before all the drama of the last couple of years, what did we actually know about WOHG 64? We've known about it since the 70s, right?
That's right. The name WOH just stands for Westerlund, Olander, and Hayden, the astronomers who cataloged it.
Ah, okay.
And even back then, they knew it was an outlier. We classify it as an extreme red supergiant, and, some astronomers argue it pushes into red hypergiant territory.
And the stats are they're hard to believe. A radius of 1,540 times the sun.
Give or take, yes. That radius puts it in the absolute upper echelon. But it's not just big, it's bright. We're talking about a luminosity of, roughly 282,000 times our sun?
Just pumping out energy.
An unimaginable amount.
But here's the catch, and this is crucial for the mystery. If you were flooding near it, it wouldn't look like a clean ball of light.
No, absolutely not. This star is messy. It's what we call dust enshrouded. WOHG 64 is surrounded by this massive structure, a torus.
Like a donut?
Exactly. Imagine a gigantic donut of dust and gas, about a light year across, circling the star.
A light-year-wide donut. That's bigger than our entire solar system.
Much larger. And this dust is optically thick. That's the technical term, meaning it's so dense that visible light really struggles to get through.
How much stuff are we talking about?
We estimate that Taurus has between 3 to 9 times the mass of our entire sun, just in expelled material.
Hold on. It has sneezed out 3 to 9 suns worth of matter.
Over thousands of years, yes. Red supergiants have these incredibly strong stellar winds. Their surface gravity is so low because they're so huge that they're barely holding themselves together. So they're just constantly shedding their outer layers.
And this dust is the veil.
It's the veil. It's vital to the story. It absorbs a huge amount of the star's visible light and then re-emits it as infrared heat. It's like trying to look at a light bulb that's wrapped in a thick wool blanket.
You know the light is there, but you can't see the filament itself.
Exactly.
But we did eventually get a peek at that blanket, didn't we? I see here 2024 was a huge year for actually imaging this thing.
It was a historic milestone. The VLTI, the Very Large Telescope Interferometer, captured a direct image of this dusky torus.
Can we just pause on the VLTI for a second? I think we gloss over how hard this stuff is. You're taking a picture of a star in a different galaxy.
It's incredibly difficult. I mean, usually stars outside the Milky Way are just dots, single pixels of light. Even with Hubble or Webb, you can't resolve their shape.
So how does interferometry work?
It's a brilliant hack. You take multiple huge telescopes, in this case in the Chilean desert, and you combine their light signals. It effectively creates a virtual telescope as big as the distance between them.
A massive zoom lens.
In a way, yeah. It gives us the resolution to see details on these tiny scales. And because WOH G64 and its dust cloud are so massive, the VLTI could actually resolve the structure.
And that was a first.
The first ever interferometric image of a star outside our own galaxy. A huge deal.
So that's the picture. A giant dying red star hiding inside a massive dust donut. That was the status quo. But then the data started getting weird.
Right. And this brings us to the identity crisis. Things really started to unravel around 2014, though we didn't fully get what it meant until much later.
Historically, this star was a semi-regular variable. What does that mean in, plain English?
Most dying supergiants sort of breathe. They pulsate. They get brighter and dimmer over a pretty predictable cycle as the star physically expands and contracts.
A slow heartbeat.
A very slow rhythmic heartbeat. For WOH G64, that cycle was about 800 days.
But in 2014, the heartbeat stopped.
It broke rhythm. It became irregular. The nice, neat pattern just vanished. And at the same time, the star started dimming a lot. The light curve just fell off a cliff.
Okay, so that brings us to the explosive paper from late 2024. The Munoz-Sanchez team. They look at all this weird behavior and come to a really startling conclusion.
They did, and to be fair to them, the data was compelling at first glance. They saw that while the star was dimming, other indicators suggested the star itself, the actual surface under the dust, seemed to be shrinking.
Shrinking down to what?
Down to around 800 solar radii, so basically cutting its physical size in half.
Wow.
And at the same time, they measured the temperature rising. It seemed to jump from a cool 3,400 Kelvin up to nearly 4,700 Kelvin.
In stellar terms, that's a massive fever spike.
It's huge. A 1,300-degree jump is the difference between a red supergiant and something else entirely.
And that is where the yellow hypergiant headline came from.
Exactly. Munoz-Sanchez and his team argued that WOH G64 had physically metamorphosed, that it had transitioned from a red supergiant into a yellow hypergiant.
Why did that claim set the internet on fire? I mean, stars evolve all the time, don't they?
They do, but on time scales of millions of years. Watching a star evolve is like watching a mountain erode. You shouldn't be able to see it happen in a human lifetime.
Right.
To see a star shed its skin and become a yellow hypergiant in just a decade, that's unheard of.
It would be like watching a caterpillar turn into a butterfly in, 3 seconds?
That is a great analogy. Yeah. It suggested we were seeing a blue loop evolution in real time. The story was that the star was shedding its outer layers so fast, it was compressing and heating up as it marched toward its death.
I remember reading the articles, star transforming before our eyes. It was so seductive, we all wanted it to be true.
Of course.
Right.
It would have allowed us to test our models of stellar death live. It would have rewritten textbooks. It was a very, very exciting few months.
But science is rarely that clean. Which brings us to the plot twist, because just 2 weeks ago, the rebuttal paper arrived.
Yes, January 5th, 2026, a new paper by Van Loon and Onaka. And it essentially said, everyone calm down, look closer at the chemistry.
So they went back to the spectroscopic data from 2024-2025, the same period. What did they find that the first team missed?
Titanium oxide.
TO. Sounds like something in sunscreen. Why is this the smoking gun?
It's all about molecular stability. Chemistry is very strict. Titanium oxide molecules they're fragile. They can only exist in cool stellar environments, below about 4,000 Kelvin.
Okay.
If you heat them up past that, the molecules just vibrate so violently they break apart. They dissociate.
So if the star had actually heated up to 4,100 Kelvin, like the yellow hypergiant theory claimed?
The titanium oxide would have been destroyed. It would have vanished from the spectrum. But Van Loon and Onaka found strong, clear bands of TO absorption in the data from that period.
The molecules survived.
Which proves the environment was still cool. WOH G64 is still a red supergiant. It never transformed.
Okay, but I'm struggling here. If it didn't shrink and get hot, why did it look like it did? The first team wasn't just making it up. They saw a signal.
And that is the brilliant part. It wasn't evolution. It was an interaction.
Reaction with what?
A companion star.
The secret partner.
We've suspected for a while that WH G64 might be a binary. There were hints in older data. But the 2026 paper really solidified the model. There is a second star hiding in the glare,
What kind of star are we talking about?
a smaller, hot, B-type star. Think bright blue-white, maybe 10 to 20 times the mass of the Sun, but much hotter. It's on this very long eccentric orbit, at least a century long.
Right.
And what happened between 2014 and 2024 was periastron.
The closest approach.
Exactly. The companion star swung in close to the supergiant. And you have to remember, WOHG 64 isn't a solid ball. It's a diffuse puffball of gas.
So when you bring another star close,
Gravity does violent things.
I'm imagining tides on Earth, but a billion times stronger.
That's it. The gravity of the passing companion pulled on the supergiant's atmosphere. It created a tidal bulge. It literally stretched the outer layers of the giant.
Stretched it. Okay, so how does stretching it make it look hotter?
This is where we get into optical depth. Think of the star's outer atmosphere like a thick curtain. It's cool, it's opaque, and it blocks the view of the hotter inside. When the companion star's gravity pulled on it,
It stretched that curtain thin.
exactly, it made the curtain see-through.
Wow.
By thinning out that cool outer layer, it allowed us, the observers here on Earth, to see deeper into the star. We were looking at the inner, hotter layers that are usually hidden.
That is wild. So the star didn't become hotter. We were just looking inside it for the first time.
It was an illusion caused by tidal stripping. The shrinkage was just us seeing a smaller, hotter layer deep inside, and the heating was just the exposure of that inner core. The companion star basically peeled back the skin for a little while.
And now...
Now the companion is moving away. The tidal forces are relaxing, the skin is closing back up, the opacity is returning, and the star is looking like a normal red supergiant again.
So the Great Metamorphosis of 2024 was just a drive-by. A temporary window into the guts of the star opened up by its little brother.
Correct. And this explains everything. The irregularity, the temperature spike, and crucially, why the titanium oxide is still there. The cool outer layers didn't go away, they just got spread thin.
Science is amazing. You get this great hypothesis, it fits the data, and then someone else comes along and says, actually, gravity is just playing tricks on you.
It really highlights why long-term monitoring is so vital. If we only looked in 2024, we would have been convinced. You need the follow-up, you need the context.
So the crisis is over. WOHG 64 is back to being a red supergiant. But that doesn't mean the star is safe, does it? This thing is still on death's door.
Oh, very much so. In fact, this whole interaction, this tidal stretching, it might actually be accelerating its death.
Okay, let's talk mass loss again. You said it sneezed out suns. What are the current rates?
The rates are staggering. I mean, one of the highest known. We're talking about 3 to 5 times 10 to the power of -4 solar masses per year.
Okay, you've got to translate that out of scientific notation for me.
Imagine the star spitting out an Earth's worth of mass every few days.
Every few days. That just seems unsustainable.
It is completely unsustainable. It's shedding mass at a rate that is just hard to comprehend. And this creates that complex nebula around it, rich in nitrogen, which is a telltale sign that the star is dredging up processed material from its core and throwing it out. It's turning itself inside out.
Is there a limit? I mean, how big and loose can these things get? I've heard of the Humphreys-Davidson limit.
It applies perfectly here. The Humphreys-Davidson limit is basically a line on the chart we use to classify stars. It defines the upper boundary of stability. Above this line, a cool supergiant just cannot exist.
The outward pressure of its own light is stronger than the gravity holding it together.
Right, it would just blow itself apart. And WOHG 64 is sitting right on that line. It is teetering on the very edge of physics.
It's living on the edge.
It is. It's also classified as an OHIR star, which is another really ominous sign.
OHR, that means it's emitting masers.
Yes, masers, basically space lasers.
Natural space lasers.
The conditions in that dusty shell are perfect for it. Molecules of water, silica, hydroxyl OH, they get pumped by the star's radiation and emit these coherent microwave beams. When we see a star doing that, it's a neon sign flashing, the end is nigh.
So supernova.
Eventually, yes, it will almost certainly end as a core collapse supernova. Given its mass, it might even leave behind a black hole. When it blows, it will light up the entire Large Magellanic Cloud.
But probably not next Tuesday.
Probably not, but soon, in astronomical terms.
Yeah.
Could be tomorrow, could be 10,000 years from now.
I want to zoom out and just synthesize this because the journey is fascinating. We found a monster, we saw it act weird, we convinced ourselves it was doing a magic trick, but it turns out it was just a gravitational illusion.
That's the summary, and what's crucial is the timeline. This all happened, the change, the event, the resolution, in just 12 years. 2014 to 2026.
A blink of an eye?
Nanoseconds. It reminds us that the universe is dynamic. We think of stars as these static backdrops, but if you look closely, things are violent, messy, and changing on human timescales.
It really challenges that view and shows that even with our best tools, nature can still throw a curveball.
Context is everything.
Yeah.
We needed the images, the light curves, the chemistry, all of it to solve the puzzle.
Before we wrap, I have a thought that's been bugging me. We spent all this time on the giant, the red supergiant, but what about the little guy?
The B-Tub companion.
Yeah. I mean, imagine being that star.
The environment would be hellish.
Think about it. You're a hot, bright star. You're flying through that donut of dust. You're flying through a wind of gas that's hitting you with the mass of the Earth every few days.
The view would be apocalyptic. You'd be bombarded constantly. The sky on one side would be entirely filled by the red, glowing surface of the primary star. It would take up half the heavens.
And it wouldn't even be a clear view. It'd be this dark, reddened, swirling, chaotic mess.
It's like flying a plane through a volcanic eruption, but the volcano is the size of the solar system. And you're doing it for centuries.
A terrifying place to be.
But, arguably, that little companion star has the best seat in the house for the upcoming fireworks.
Unless it gets eaten first.
Well, given the drag from that torus, its orbit is probably decaying, so that's a possibility for another deep dive.
Thanks for listening, everyone. Keep looking up, and remember, sometimes what looks like a transformation is just a change in perspective.
See you next time.